Is it doing to do the opening?
Did you say something to me?
Yeah, I was asking if you want to do the opening.
Oh, yeah, yeah, for sure. Yeah. Shall we wait a time? Shall I, shall we wait a tiny bit more?
No, I think we should start because we have a lot of presentations today.
Okay, okay. Okay, so welcome everyone. So today, finally, you have all gone through this very hard the work time and gone through all the modules, and it's time for you to showcase your expertise and share your projects with us. And we are very excited to have you today among us. And look, we're looking forward to hear about this timeline and how you integrated all these the things that you learned throughout this course and Nebula cohort, and how this implemented and helped you with your projects. And today's duration is 90 minutes. Here you have Graciela with us, and I will be helping as your facilitator, and Bethan also will be helping and observing together with us. So we have 16 presentation today, which is pretty crowded, but also super good that we are very excited that this interest by you all to be today's graduation ceremony. I'm Ishil again. First of all, we would like you all to, I believe you all have the from a pad that I will also share the link with you again. So you can have it and start getting your names written down. If you haven't shared your presentation slides, please also find your slot and add your slides there for others to also have a gaze through when you present. We also would like you to share your name, location, and also something that is like an icebreaker. What are you looking forward to do with this extra hours soon you're gonna have when you'll free up in your calendar to also celebrate this amazing achievement you have obtained throughout this cohort. So always, we have to be careful that turn on your webcam if you don't mind, because we are recording, and also, this whole session is transcribed, and we will have as soon as the session is done, and we will have the videos ready to be available on YouTube channel. We, of course, this community cares about each of its members, and we have a code of conduct and participation community participation guidelines. You can find the links in the Grandma path. We encourage everyone to participate and are committed to building a community for all. Be considerate and respectful, and remember that we are a worldwide community, so you might not be communicating in someone else's primary language. So if you experience or witness unacceptable behavior or have any other concerns, please report it by contacting the organizers, Sarah and Graciela, through team@weareols.org. And to report an issue involving one of the organizers, please email one of the members individually, either Sarah or Graciela, by the emails below. So again, I'm today your hosts, and I guess we are good to start. And the first presenter is uh, Yorley Santos, if I'm reading correct. Are you ready? Uh,
Yes. Hello.
okay.
Hi.
Hello. Hi. Okay.
Is my audio okay?
Yes, I guess you should be able to share your screen for your presentation. Let's try.
Okay,
Have
just a
any
moment.
issues, just let us know.
Okay.
I will be
So,
monitoring the questions if there is any, but we will raise it after your presentation. And just be mindful of we have a very a good lineup today and a number of people. So just to be careful with the timing. And we will also remind you the timing too. So
okay, so is my screen being shared right
yes,
now?
very
Okay,
well. Yes.
so
Okay.
so thanks.
Off you go.
So, hello everyone. It's good morning from here in Brazil. Good afternoon, maybe, but I'll be presenting to you what I have been able to learn throughout this past few 6 weeks with you. And the title of my presentation is Applying the Principles of Open Science to a Gut Microbiome Analysis Pipeline, which is basically my work. My name is Jorge Santos. I'm a Master of Science student in microbiology from the University of São Paulo in Brazil. So first, talking a little bit about my work, I'm starting master's studies, which is basically will be responsible for analyzing a cohort of patients which have been diagnosed with autism spectrum disorder in Brazil. And since I'm working with microbiology, we will be analyzing gut microbiome and DNA sequences collected from these patients in order to create a greater comprehension of some relationships that have been highlighted in the literature regarding the connection between the brain and our gut, specifically the bacteria that live in our gut. There have been some reports regarding the potential impacts of the microorganisms that inhabit our gut that could produce some substances that potentially could impair some neurodevelopmental processes. And we're trying to understand a little bit how that could relate to autism spectrum disorder. So going to the topic of today, which is open science, I work with bioinformatics, with DNA sequences, with files that are deposited in online that I need to share with some sort of open access platforms. And most of the time, my research involves the development of pipeline, which is an Xflow scripts with Python, and the execution of a statistical analysis. So there's a lot of code, there's a lot of data management, and I would like to share a little bit what I learned that I could improve about my work thanks to the work that you guys presented to us throughout these weeks. So basically, my main question is, how can I properly implement open science to my research? Because I knew open science was important, but it did not come as something grounded that I actually knew precisely what I should do. I just knew it was important. So my main learnings, and you can already see on the right, some of the licenses and GitHub that we've been talking about for the past few weeks. First, the cohort training sessions presented a captivating introduction to me on the importance of license usage in scientific research. I knew they were important, but I truly did not understand specifically what was the difference between CC BY, and C, or what does it mean to share it as a share alike license. So these specificities, which I was constantly reading after some of the classes, I actually realized that I was reading these licenses all the time. I just didn't have the specifics to actually understand what each of them meant. But this was something that I realized that it is really present in my everyday work, and I'm really thankful for everything that you guys have presented to us. Alongside everything, but this one is something that I really got my attention. So since I work with human health data, some discussions and activities focused on the relevance of anonymization and the limits to what we can share were particularly useful. We had some really important discussions regarding that open science is truly important in so many ways, but it does not mean that we need to share everything, because we need to consider ethics. We need to consider the safety of people that are included in our research. And these discussions really fostered some ideas that made me mature what I actually understand by the necessity of doing open science, but also the need of actually having limits to what we can share. And specifically about the coaching session that I had with Professor Niasita Ondari, I was able to discuss about the preservation of intermediate and raw data in bioinformatics, since she's also a bioinformatician. And one thing that really got to me was that she highlighted the importance of public repositories to her work. She actually mentioned some aspects of her research about her career, which was really impacted by the use of public repositories, and that really got to me. So regarding next steps, I understand that I want to develop an open by design approach to the activities developed in my Master of Science activities. As I mentioned in the beginning, I knew open science was important, but actually planning open science from the beginning of the work is something that I feel more prepared thanks to everything that I learned here. I understand that adapting my GitHub repository for this project will help to facilitate reproducibility of the steps executed in the main analysis pipeline, specifically quality control, metagenome assembly. Bioinformatics is a field that can be quite tricky, and actually having these adapting my GitHub to what I learned with you will take a little bit of time, but I think it's worth it. And finally, which is a little bit more about humans, is the fact that I need to discuss with other collaborators the benefits of investing time into implementing a properly structured open science approach to our project, because I really want to, but there are other people involved, and this is something that I need to take into account moving further, discussing with others. There's this image from UNESCO, which I won't discuss further so I won't delay the other presentations. And that's it. Thank you for your attention. This is my email, my LinkedIn, and I would really like to thank meeting some other students like Anu, Osinke, Maite, Fotis, Steven, some people that I met here that I was really happy to, talk about science with others. The breakout rooms were really important for me too. And that's it. Thank you.
Thank you. It was fantastic. If you have any questions, did I pronounce your name correct? Sierra-Lee?
Yeah, I
Okay.
always joke that there is no right pronunciation. My father created this
Okay.
name. I do not even know from where,
Okay.
but thanks. It was right.
It's beautiful name and happy to know you. It was
Thank you.
fantastic presentation and very inspiring, and to see that especially the practical aspects of the whole cohort was really helpful for you. I don't know if you have any if anyone has any questions to raise, but if you otherwise, from a Patties for that reason, you can raise there, and anyone can come back and answer later on in a further, more wider time. So I guess because of the time concerns, Grisel, shall we move on? Or are we happy to move on?
Yeah,
Okay.
I think so. Unless someone has a question or comment or feedback for Jolie.
Okay, someone already wrote this beautiful slides, and I agree too. Very nice, very neat, and very smooth presentation. And time was super perfect. Okay, thank you. Okay, so I guess we can move on with hopefully you will go back to from a pad and find out questions there too. So we will meet with Lani Rokos. Are you ready, Lani?
I am. I will share my screen.
Okay, perfect. We can see your screen.
Great. All right.
Okay,
Uh,
guys.
yeah, I'm Leanne, and I am currently a research technician at the Institute for Neuroscience and Neurotechnology at Simon Fraser University, and I completed my PhD at the Institute of Medical Science at the University of Toronto with a focus on developing computational models of early childhood brain networks. Across my lab and the Institute and really the university as a whole, we have a strong emphasis and goal on improving our research practices to make our work as open, transparent, and reproducible as possible. So this course has really been particularly informative for my current role. I'm responsible for developing and supporting open software for multimodal neuroimaging processing and brain network modeling using an open source community-driven platform called the Virtual Brain. I'm also responsible for developing open statistical analysis tools. For example, I'm responsible for transitioning our workflows from more proprietary software like MATLAB to Python to improve accessibility. I also help design and maintain our databasing and project management systems and support the development of various training workshops. And With what I've learned in this course, I feel well equipped to help support research projects within the Institute to really align with open science best practices from the start and to design more accessible tools and training resources as well. So that connects to one of the key takeaways from this course for me, especially from the coaching session that I attended, which was the importance of community engagement and a lot of really useful strategies to do so. So we discussed the importance of clearly communicating the benefits of open science that have been really nicely mapped out throughout this entire course, and really demonstrating or emphasizing how these practices can broaden the reach and impact of research. Another important point was the value of sharing practical tools and resources that make it easier, not harder, for students and researchers to conduct and share their work, really framing open science as a more efficient and supportive approach rather than an added burden or an extra layer of work. And through this course, I've learned about an incredible number of practical tools, and the recordings themselves will also be, I think, a really helpful resource to share as well. Another key recommendation was creating regular opportunities for discussion, training, and knowledge sharing, as well as leveraging existing university infrastructure and central support. So looking ahead to some of the next steps for me in terms of putting everything that I've learned through this program into practice, it includes openly sharing code data and workflows and submitting preprints from my PhD work, as well as future manuscripts. Another important goal that I have is to more actively engage participants and broader research communities to make sure that the work we do is connected and relevant and responsive to the people that it ultimately serves. A further key focus for me includes not only developing and sharing open training materials and workshops that introduce tools and workflows, but also helping others to build more practical open science skills, such as creating data management plans, developing well-documented GitHub repositories, and adopting reproducible research practices. So beyond learning individual tools, I hope I can also help researchers understand how these tools in themselves fit within the broader open science framework and encourage the adoption of other open science best practices. So I guess I hope to create resources that are reusable across projects and accessible to researchers at different stages so we can move towards practicing open science by design, where it's not something added at the end of the project, but something built into the research process from the very beginning. And yeah, so I'd just like to thank the OLS instructors for all their guidance support, facilitating these really important discussions and sessions, as well as all the other attendees for some really engaging conversations.
Thank you, Lenny. You were even earlier than the time is perfect, Sunny. Thank you so much for keeping it up with the time. I don't know if there's any questions, Lenny. Please just leave them and again from Pat. So she can always come back, and it's super nice to again hear another medical graduation cohort that you had the chance to benefit from all these resources and tools to know that have to implement into your practices, and obviously finding a good community that also appreciates these practices and creating this community if it were necessary. Super important. So we wish you very exciting good luck for your project and implementation. So all this incorporating all these tools that you learn over the time. So we're gonna move on with the next presenter, Carolina Taniguchi. So I don't know if she's here. I can see, but Carolina? Oh no, okay. Okay, let's skip for now. So maybe she will join further. And the next one on the list is Victoria Paroman. Okay.
Yes.
Okay.
Yeah. Thank you so much. And I'm so sorry that I have not prepared a slide for this.
Okay.
Right.
So-
I'm just going to go on.
Okay. Okay. So, I mean, would you like to discuss a little bit how you benefited from your from the cohort, or so do
Yes.
you?
Yes.
Okay.
So yeah, I'm going to talk about like my journey through the
Okay.
course. Yeah.
Okay.
Okay, thank you so much. So
Stage is
my name is Victoria. Hi everyone. And I mostly like to refer to myself as an open science contributor because everything I do like kind of circles back to that. So in the last 3 years, I have been a volunteer, I've been a mentee, and I am currently now a mentor for an open science program, Outreachy. I don't know if any one of you are familiar. Currently, I'm also a contractor with Crossref. So this program really, resonated with me because, like, at the core of what we do is making sure that research is accessible and citable. So the reason I joined the Nebula, NASA program is because like I'm at the point where I'm trying to get back into academics, and the program just felt like a very refreshing start for me. So I'm really glad that I followed through. Thank you so much. And for the key takeaways, some of the things that I have learned from this program is that, open science is not just about open research, it's also about transparency, and it's also about inclusion. And a very key one that I would like to make mention of is from the last session with Dr. Daniela about open science publications and preprints. Something that she said, a particular question that she asked, kind of summed up the whole program for me in a very, very beautiful way. And, she said, if we do not share our research, then what really is the point of doing it? I honestly agree with that, because if it's worth researching, then it's certainly worth sharing with others, our community, and all of that. So my next steps after the program, they are very personal, and they're also very, very community related. So first of all, I've always felt that there is a huge gap in like the open science awareness where I'm from. I'm from Nigeria. And the last session, it became even, more glaring. Take, for example, in my undergraduate years, I did a research project about the bioabsorption of metals using microorganisms that were cultured from the environment, dirty water and all of that. And all I got was a clap, like, "Oh, nice work." And that was it. That project is sitting in my school library, which is very far from me. I do not have access to it except hard copies. And so this whole program, and especially the last session, just made me realize just how much more, I would have gotten from that project, the insights, the feedback, everything that I would have gotten from it if I actually put it out there. So I think one of the next steps for me would be making sure that through my community, I am able to create this awareness about open science and just how much, early career scientists who are coming after me are aware that they can put their work out there. And also for personal reasons, since I'm looking into going back to do an MSc and study the microbiome more, I hope that my future research would see the beautiful light of day, and I would make sure that, that happens. Also, I've joined the pre-review community, and I'm hoping that, through that, I'm able to like grow my passion for peer review as well, and, connect with more like-minded people from, that community, and also like stay in touch here. So yeah, I think those are my next steps. Thank you all so much. I had a great time. Thank you so much.
Thank you, Victoria, for sharing your journey with us. It's super inspiring. And also, the one other thing you said already is the main aspect. So, the not just learn by yourself, but carry these practices into your community is the best way to actually make it even more spread more widely and adopted widely, because you will be like one of the inspiration for them. So we wish you good luck with this endeavor, and thank you for sharing your whole journey. And if you have any questions for Victoria, again, same, just go to from a pad and right there. So we will move on again for the time purposes with the next presenter is Elaine Brace Touche. Is she, or are they here? Elaine? Oh, okay. So I guess I will move on, but maybe they might join in the further time. Okay, I will, because they shared their presentation, and let's see if they will show up. And Michael Maliburn, let's see. Yeah, Michael Maliburn, I can see you. Can you hear us, Michael?
Yeah, I
Okay,
can hear you.
perfect. Okay, so just try if you have slides and just sharing. So let's check if it's working for you.
Is it okay for me?
So do you have slides, Michael? I guess you.
Yes.
Yeah. Okay. So okay, I can see. Perfect.
So they're showing now, are they?
Yes. Okay. Perfect. We can see it. You can go ahead.
Okay, brilliant. So I'm Michael Maliburn, work at MFT, which is a hospital trust in Manchester, UK. So I'm not exactly involved in research directly these days. So I've tried to come up with a talk that kind of aligns what I'm doing with the open sciences as much as possible. So we'll see how it goes. I previously did research in nuclear physics and then engineering, mostly building detectors and acquisition systems, and also managed a computer cluster for simulations. Now I'm more in the IT side of things. I'm working in a trusted research environment, which helps researchers access data in a secure way that they can't exfiltrate all of the row level data, and so we can ensure that things get aggregated properly for legal reasons like GDPR and stuff that we have here. So I'll just go to the next slide. I'll try to go to the next slide. There we go. So one of the things we are doing is this TRE. It's based on an open source project, and in terms of the sort of contributions we make, we benefit from it being open source. Microsoft have open sourced this project and they maintain it, and we use that project in production. And what we gain, so our experience in running it in production often comes up with issues that were not originally thought of when this thing was designed. And what we try to do is feed back what we've learned into the upstream code. And there's a couple of examples, so I'll just sort of focus on a couple of them. The way that the sort of interface for people, so researchers have to do work in it, and then they basically submit a request to export data, and we have to validate that is according to legal requirements and stuff. So we have to approve or reject decisions, and the way the user interface was, it was very easy to just accidentally click the wrong button and make the wrong choice. And so we fed that back, and what that led to is there's now a confirmation to make that mistake harder to do. And there's also an extra feature that allows you to, if you've previously approved something by mistake or later on it became apparent it was a mistake, you can now revoke that decision, and so no further download of that data can occur. So those are two sort of positive outcomes we've had from contributing with the upstream Microsoft with the upstream project. So not just Azure TRE, but we do have other projects we use, and we try to contribute where possible. That kind of brings me onto this slide, which is mostly what we do is a very small part of a bigger thing, and we know we're not contributing much, but there are many people contributing a small amount, and the result is you end up with a system that is more secure for everybody, and everybody benefits. Everybody who wants to use this project has those improvements built in. And this can be done in many different ways. So I focus a lot on coding. So I see a code a lot. Most of my contributions are there. But there are other ways to contribute, and we do try where possible. Sometimes we've done doc fixes and stuff. Yeah, so you don't always have to contribute a lot, but what we do, we think makes a difference. In terms of trying to apply what we've learned in the training to future examples, this is one of the projects I'm currently working on, where we essentially take images, and they're stored in this format called DICOM mostly for medical data. And we just want to strip all the patient identifiers out of it and produce something that's completely pseudonymized, which means we can re-identify if needed, but the researchers can't. So to them, it's completely anonymous. And we've built that again on open source technologies, and we hope to make this open source. But as we work in the NHS, and I've put a caution on this slide because there is a risk that companies see open source as a risk. And especially with LLMs that can find all the bugs in your code and then possibly exploit your organization. So I think it's important to recognize that risk and mitigate it properly. But the value of open code is that good people can see the bugs and help you fix your code as well to reduce those vulnerabilities. And ultimately, that is a preferred strategy among security experts. So the final slide is just to say that I think one of the main takeaways from the training is that I was focused on more open source and somewhat open access publishing. And I think it just made me realize that it's bigger and there's more to it. So that's kind of a general idea of what I've learned. And then something specific is just I actually didn't know you could cite databases with DOI. So just that's a good thing I learned. We'll probably use that in our organization. So that's all. Thank you very much.
Perfect, Michael. Thank you. This is very inspiring. And one of the things we learned throughout the open science, I guess, yes, we all understand the whole spirit behind it, and we really want to be part of it, but it's always costly. There's few incentives for the organizations if you want to participate, and their infrastructure costly. Learning all these skills are costly, and having someone like you and your colleagues and providing us these platforms and tools to make it even easier is invaluable, and it's super. It's of course your university taking the steps and helping researchers to create this team and this infrastructure behind is amazing, big contribution, and your contribution is again so providing all these means and tools is extremely helpful that I know from myself in the same way that you're dealing with all this anonymization of the data and making sure that indeed in the era of AI everything can be quite messy, and helping out with this practices is amazing. Thank you so much for doing it and incorporating all the learning that you had through the cohort into your practices. If you have any questions for Michael, do you have a question?
No, I don't have a question. I'm Alan. You just called me. I was trying to share my screen. I'm Alan.
Okay. So are you the one next on the okay.
Yes, I was trying to share my screen.
Okay, but are you on the? We can go ahead with you if you would like. So I couldn't see you in the list, but do you want to go ahead?
Yes.
Okay. Okay, let's go ahead something.
Okay. Is it okay?
Yes, we can see it.
Perfect. We can see.
You see my screen?
Yes.
Huh?
Yeah. Oh, okay. I can hear you. Go ahead.
Okay, please, it's my first experience. That's why I asked if you can see my screen.
Yes, we can see your screen.
Okay, thank you. So I'm Alain. You follow this plan. Okay. About me, I'm certified teacher of secondary and high school. I'm final year PhD student from Cameroon country, Central Africa. I'm lab manager from cancer research unit. I already involved on 3 open science programs, start by open science instructor training from LNU Germany, Zoma School last year. I'm also currently ELA Community Ambassador training. It's a program of 18 months. I'm currently part of this long-term program of 9 months, Africa Opportunity Network. Yes, hello. My key learning for NASA OLS program, first, I personally learn about ethics of open science, normally idea that made me very simple, inclusive, diverse, equitable, and accessible. About now open science spectrum, I learned about how to start with outreach people, then get involved, use Zenodo or repreprint, and then start really practice open science with data sharing, method sharing, and also open peer review. And finally, the last stage, be a trainer for community. Also about open data, I learned about non-open data format and also open data format. For data management, the key learning was the different questions that you should consider. The what for standard format, the when, the time to share, where the appropriate repository, and the how to plan to use data, and finally the whole team. Now my lesson was about open result by using PRC model, P for preprint, review, curate. Finally, I find this program really welcoming for me. It's also inclusive because I also discovered that some trainers from Nigeria were also involved, like say Olonfi. I found the program very flexible. And I also invite other fellows to deepen their knowledge with Africa Opportunity Network YouTube channel to further learn about open science. Now, my next step, because I'm currently a PhD student, I'm planning to apply preprint of my last thesis article. Also plan to start share what I learned, organize workshop in my own department. I also wanted to continue to deepen my knowledge because I'm really interested by open science framework that allowed us to have a reputation workflow. Also pay attention to Turing way. I also in the future become also a trainer for this program. Yes, by being more specific teaching about dataset in OSF that I already master and by considered real model. And finally, like this one, a previous fellow of the long-term program of OSL, normally Dr. Omar Ahmad, I also plan to fund OSC CAM, Open Source Community Cameroon, because here we don't have any community about. So I will finish my presentation by thanking all the NASA OSL team that allowed me to start also involved in open science. I do my first sharing in Zonodo. It's my first online communication. I also want to thank especially Sarah Villa that allowed me to join the program after deadline. Thank you.
Thank you, Alan. This was fantastic to see. Like you are involved with a lot of other communities and networks, and again, you're gonna be willing to be an ambassador to share this knowledge you gain through the program with your community is very inspiring, and also you are planning to continue with next OLS cohort. This is really amazing news. Apparently, we achieved what we intended to do so and leave a good impression and impact on you. So thanks so much for sharing your project with us. And so if you have any questions for Ellen, again, use the from a pad to leave your comments there. So And from this point onwards, I wonder if we missed anyone, someone who didn't share their slides there, maybe. So, or
Yeah,
we're
it
gonna
seems
move
like
on.
we have three more people in the list, but I thought we could have a break and watch some recordings now
Okay,
because we're
okay, cool.
really early. Yeah, we got
Okay,
really good on time
okay, perfect.
and we got one no-show, so we're good in time. Um,
Okay.
in the meantime, I wanted to see if someone wants to comment something about one of the presentations or if you have any questions at this point. Oh, good. I'm preparing to share Prasad's recording. Okay, got it. Scream at me if you cannot hear anything,
Yeah.
okay?
We'll
Thank
let you know.
Hello everyone, my name is Prasad Sudhat. Today I am going to speak about the OLS Code 4 program takeaways. I am going to speak about the topic Open Code. Before diving into the topic of Open Code, I would like to give a brief introduction about myself. I am a research software engineer working at the University of Bristol. I have worked as a software engineer in the corporate field, and I am also giving on-demand training within the institutions to the newly joined PhD students and researchers. I provide training in the software languages like Python, Java, C#. I have completed my master's in robotics from the University of Bristol, and I am also a BE mechanical engineer. I like to play sports. I especially enjoy badminton, football, and pitch and putt golf. Now let's dive into the learnings from the session. The session focused on principles of open code, also gave information about the restrictions about the code sharing, and the speaker also shared several resources. I thought learning about principles of open code made me feel more confident about contributing to the field of open science. I am encouraged more to increase the transparency, make my code more inclusive, and make it more collaborative. I also felt aware about learning when not to share the code, especially when it contains a sensitive piece of information. The concepts related to software types, licensing, use of LLM were highly informative for me. They created a sense of awareness, and after going through these concepts more thoroughly, I am now able to clearly distinguish between a library and a modeling software. I am now clearly able to go through different types of licenses available and select the one appropriate for my particular project. And a discussion over LLM just broadened my perspective related to the use of AI. There was also one more resource shared related to a big code project, and I'm right now going through the information provided on the resource. But in general, I felt like the resources and the concepts shared in this talk were highly informative for me. Moving on to the next steps. I've decided to publish more blogs because after going through the resources that were shared within this session, I felt that writing a blog gives you a good and effective way to contribute to the community. I also found out that having a good visual representation of version control while using those commands is very helpful, and I'm going to try and integrate that more within my training resources. I've also missed on assigning DOIs to few of the repositories that I've contributed in the past. So that is going to be my next step, that to assign DOIs to the repositories that I've missed. And overall, I've found that interacting within the community, made through be a Slack channel or joining a carpentries group, is highly important because it gives you more information, it makes you more aware, and it gives you the sense of belonging to the open science community. Finally,
I have also developed several training materials for the institutional training that I provide. I intend to publish them on GitHub in order to invite collaborations and contributions to the entire open science community. I will also try and enable the discussion threads on the blogs, as that can also serve as a good purpose to contribute to the topics that I'm going to write. To start with the next steps, this is the example of the current project that I am working. This is a calibration scale conversion tool. This tool can be used within the atmospheric chemistry diaspora. However, this tool currently lacks a DOI and also a proper tutorial explaining full capabilities of the calibration conversion tool. It only contains a small example at the moment. So, like I said, I would start writing a tutorial that explains this particular project in detail, add a DOI that can be linked to Zenodo, and this would be a good project for me to start implementing the learnings that I've learned in the OLS sessions. Finally, I would like to thank entire OLS team and the open science community that I've got in touch with, and I'm looking forward to contribute and also collaborate for more open science projects.
All right. Congratulations, Prasad. That was very nice edited. Very good video. Please add your feedback and comments to Prasad on line 159 now on the front page. I'm going to play another recording for Cheng Li. Need to stop sharing this. In the meantime, feel free to unmute if you have any questions or comments, or if you want to go first because you need to leave, that's also fine.
Hello everyone, my name is Cheng Li. I'm sorry that I cannot attend live today, so I have prepared this recording. In this short presentation, I want to share how Nebula has helped me think about open science in a more practical way, not only as a set of values, but as a design question. I will use OPSIHack, a community event that I'm developing in Zurich, as an example. My starting point is my scientific training. In my studies and research, I have used documentation, code, Git, shared infrastructure, and repository-style archiving. During my postdoc, I joined a non-profit association called Open Innovation in Life Science. Within this association, I have been developing an open science hackathon called OPSIHack. So I wanted to move beyond my own good research practices. I wanted to understand how open science can support teams, new corners, training, and community building. This is why OPSIHack became a useful test case for me. Together with my colleagues, we had an initial idea on the working theme, which is less waste, more discovery, open tools for sustainable, efficient, and reproducible research. We are thinking about waste in a broader way. There is environmental waste in labs. There is data waste when datasets cannot be reused. There is duplicated efforts when workflows are not shared. And there is knowledge waste when negative results or failed protocols disappear. So my design question is, can a hackathon help people build practical open solutions to these problems? Nebula gave me a lens for event design. First, ethos means people first. This includes lower batteries, clear roles, onboarding, accessibility choices, and a visible code of conduct. Second, open tools, data, and code are not only final outputs, they are part of the process. This means shared notes, templates, and documentation from the very beginning. Third, open results mean reuse by default. This includes licensing, repositories, synodal feedback, and the plan for handover or maintenance. For me, these ideas turned broad open science values into concrete design choices. By applying these, the event now has a more detailed shape. So our participants will work in interdisciplinary teams with support from mentors, speakers, and juries. We do not require advanced coding experience as most of the hackathon does. The goal is to make participation accessible to people with different skills. The expected outputs are a final pitch with a practical solution, like a workflow, a dashboard, and such, with next steps plans. And the design goal is to make this rather short event live reusable. I now see two layers of reusable outputs. The first layer is what participants create. Their work should be understandable and potentially reusable by others. The second layer is what organizers leave behind by us. So this includes openly shared different types of documentation and an evaluation loop. So my next steps are quite concrete. In July and August, I will continue to shape the program. Then in August and September, the focus will shift to participants. Then after the event happens in early October, the open science work continues. We need to archive the outputs, collect feedback, prepare reporting, and identify follow-up opportunities. So for me, this is an important lesson from Nebula. Open science does not end when an event ends. It also depends on what remains useful afterward. I want to thank the Nebula team, all speakers, especially Aman from my coaching session, and the whole cohort for the conversations and resources. Thank you all for listening. I would be very happy to receive feedback, ideas, or connections. Again, I'm sorry that I cannot attend live today, but I look forward to following up afterwards.
Awesome. Congratulations, Chang. Yay. That was great. That's such a great project. I love to see these hackathon. I took a look at her notes while she was in the program, and I was like, oh, that's so interesting. And I thought it was great that she's welcoming non-coders to the hackathon as well. I always wanted to experience a hackathon, but every time was
It's
very code heavy.
it's intimidating, but actually there's always something to do for anyone, like is the I guess main aspects of hackathon. It's good
Cool. Yeah.
there, just even
Maybe.
documenting and helping.
Awesome. Maybe next one I'll join. Okay, so I think we can move on with the presentation, with the live presentations now. I think Natalie is next.
Hi, just give me 1 second. I'll share my screen. Can you see that? Yeah, okay.
Yeah, I'll see.
So hi everyone, I'm Natalie and welcome to my presentation. So I'm a grad student at SFU in the Department of Biomedical Physiology and Kinesiology. I'm very new in the program, but my research interests and where I want to go with it include women's brain health and healthy aging. I'm currently working on starting my first project where I'm going to be looking at hormonal, metabolic, and physical activity factors as an interconnected vulnerability profile for Alzheimer's disease risk in women. Alongside that, I'm also working on a side project applying open EEG data to a more practical question of how few recording channels can we get away with and still reliably get a measure of brain signal complexity? And that's where I'm going to be able to start putting the open science practice into place. So coming into this course, I roughly knew that open science was about accessibility, transparency, and collaboration. But what I didn't know yet was how to put the ideas into practice across the entire, I guess, like life cycle of a project instead of something that's just done after publication. So one of the earlier sessions introduced the idea of being open by design. So open science starting at the research idea and the study design, not after the data has already been collected. And I think this session was very useful to me because it drew that clear line between treating openness as a final step and just sharing your results and actually building openness into your project from day one. And for me, this reframed open science is something that matters from the proposal stage before you even get your data. Another takeaway for me was with the data management plans. So being in the early stages of my program, this coincided almost perfectly with me starting to write my very first data management plan. So the session kind of gave me the why behind something I was already starting the what of, if that makes sense. And finally, something I picked up from the sessions, but also just conversations in the breakout rooms, is that everyone is scared to share their code, no matter their skill level. It's maybe not as educational of a takeaway as the other two, but as someone very new to coding, it was really reassuring for me and took some of the pressure off that I'd been putting on myself and made me feel a lot more comfortable about sharing my own code openly going forward. So going forward, I'm going to be applying what I have learned directly to my current and upcoming projects. Since the data I'm using, I mentioned, is already open, I will share my documented and version control code and workflows, and also share the process results when I get to them. As I mentioned earlier, the DMP session overlapped beginning my DMP, and this helped me understanding what to do within a DMP. Even though the raw data I'm using is already open, the plan still will cover the other elements like how I'll handle and share my own derived outputs. And I feel like this will come very useful in my future projects going forward. Just covering broadly maybe how other people could contribute to that would be if anyone with their own EEG data can test whether what I find holds up beyond my data set, and also when the pipeline is published, anyone working with a similar issue can build on it. Yeah, thank you for your attention, and thank you for the Nebula program and the cohort for the experience.
Thank you for sharing your experience with us, Natalie. So it's really inspiring, and especially in that sharing in the earlier stage, of course, you feel confident, and sharing is always a good practice because eventually we are human beings. Everything can be error prone, and having other eyes and looking at your code or your data structure or something might be missing that you might discover further along the way that might be more detrimental than the things are caused at the very beginning, both useful for you, and as you mentioned, it's good for the others to adopt the similar practices who might be dealing with similar sort of problems at their own. And it's always and you finished earlier, by the way. Thank you so much. Earlier than the exit. And thank you for sharing all these inspirations, and hope everyone followed and found a similar kind of lessons to be learned to participate in open science. And if you have any comments for Natalie or any questions, so we have her in the from pad, so just you can share it there. And we will move on with Lillian. I can see Lillian. So are you ready to talk through us your experiences? And like,
Yes, I am. Can you see my screen?
perfectly. Thanks so much. Go ahead.
All right. Good evening, everyone. So my name is Lillian and I am from Nigeria. I want to talk about reproducible health research in low resource settings coming from a Nigerian. So let's see. I am a healthcare researcher specializing in bioinformatics. I was happy to hear the first presenter talk about bioinformatics. And I am also a facilitator in digital literacy. So I train people on how to use digital tools. So I basically bridge the gap between what we do here and the global standards for research, especially in constrained environments. Then my work is, well, bioinformatics research requires a lot of computation, and there are limitations that I've experienced in my work because where I am is a low resource setting. So we have challenges like access to reliable power, internet, advanced computing resources, and it's difficult to reproduce research workflows because they might be great on paper, but they might not work in practice because of the context in which they are used. So my current research is in Mycobacterium tuberculosis, a genomic analysis, comparative genomic analysis, and it shows how we can use open data sets because I got my genomic data sets from a repository, a repository, NCBI, and it's possible to conduct a research on that scale using some tools. I tried the command line tools and it required a lot of computational power that I wasn't I wasn't able to get. So I had to explore several options and I found that there are compact web-based and cloud-based tools like Galaxy where you can run an entire project and have several tools to work with and you're not limited to just command line tools or having to download or cloud storage. Then my key learning from the OLS program is that open science practices should and account for real world constraints. So it's not just to have practices, it's not just to have some really beautiful workflows. It should consider what the context is for the researchers. Can you apply what you are learning or what you have seen? Can you reproduce it in your own context? Then accessibility is very important. You can use the most beautiful tools, but if your research is not accessible, then you cannot, your research findings will not have as much impact as it should have. It's important for what you do to be simple and clear. I learned that with the metadata, like the metadata will tell you a lot about the research. So if you're just somebody who stumbled on it, you have an idea what's going on and you're not completely lost, then licensing can affect how accessible your research can be. You can produce the most amazing work and have the best intentions for it to be open access, but the license you choose could restrict access to what you have done. And I was really glad to hear people share their different perspectives, especially the presenters from different sectors. It was great to see that there were challenges that were persistent through several sectors. It's not limited to one context or another. So what OLS changed for me is that OLS reshaped how I think about research and collaboration. So it's not about how sophisticated your tool is, it's about how reproducible and accessible what you do is. And I had a better appreciation for open documentation, knowledge sharing, and community-driven research. If people are able to collaborate on the work you do, the tendency of you to finish the work faster is higher and the impact is greater. I mean, I'm very much community driven right now. Then next steps, I plan to build and share reproducible research workflows, especially for the research I'm doing, because I'm working on MTB species that are sort of restricted to West Africa. That's a Mycobacterium africanum. So I intend to build and share reproducible research workflows, make the data sets and the code openly accessible where possible, and to embed these practices into digital literacy. Because if people don't know what's going on and how to access what you have done, it is limiting. It is limiting. The impacts of your research is well limited. Then how others can contribute, they can use the workflow for their own research. They don't have to create something from scratch. If their data sets are similar to mine, they can just reproduce what I have done. Then they can contribute to improvements in the pipeline. They can also apply it in their different contexts. Then they can enhance the documentation and accessibility. The main goal is a community-driven research process. So for my final words, I am really grateful to the organizers. I am grateful to my colleagues. The breakout sessions have always been interesting. I usually learn a lot, and meeting other researchers, seeing other people in my field, it's really amazing because bioinformatics researchers, there are not as many as I would want them to be, but I'm really glad that it's a sector that is gaining more attention. So thank you so much, OLS team. I have learned a lot. Thank you.
Thank you so much, Lillian, and sharing your experience with that. And I just want to say you articulated so well, so it's super inspiring to listen to you. Like it was very coherent. You shared us all glimpse of what you gained from this whole program, and two things you touched was super nice to know that. Sometimes we have a very narrow focus just because of the area or field that we work, and we think that these problems only belong to us. But you said that in the breakout rooms, engaging with other scientists from or researchers from other fields, and knowing that everyone have different kind of struggles and the same with the same sort of or different kind of implementations with regarding the same aspects to see how they deal and how you find inspired, and also the technical challenges you had. And always there is a tool if you search for it. There is some facilitator tools, again thanks to the open science initiators and contributors. There is something that you can benefit from, but just to look for it and know that that might be exist. And it's super inspiring that with Galaxy tool you mentioned. Again, if you have any questions with her, like please share in the from a pad. We congratulate you with your graduation, and we will move on with Georges Salavotis. I guess you're here, so okay, yeah.
Hello, I'm here. Hi,
Hello.
how are you?
Okay, can you try to share your screen? Let's see if this will
Yes,
work.
I will. 1 second, please.
Okay, perfect. So you're gonna have 5 minutes, and if there's any questions, we will raise through the chats. I just saw you entered, so I'm just repeating some things for you. And otherwise, people leave comments on the Frema pad, so you can always go and add here later on. Okay,
Yes.
go ahead. Stage is yours. Thank you.
Thank you very much. Thank you for allowing me the time to have a later slot. As I said, I couldn't make it to the earlier ones. To introduce myself, my name is George Kalavoudis. Sometimes I'm called Georgios. That's my full name. I'm based out of the UK, and I'm not a researcher by any means. I'm actually more of a very detailed-oriented, hardcore engineer. And I have quite a few years of experience in the industry where I assist researchers in capturing measurement data from the various types of test equipment that they work with. And so all my qualifications are on delivering code to a certain standard. But the counterpoint to that is that because I run a consultancy, often the work is leading towards commercial solutions, or in other words, proprietary, non-open solutions. But more and more, my consulting services are being steered towards government-related or government-sponsored or government-adjacent commercialization projects where you have spin-offs coming out of universities and things like that, where I would like to use the education that I'm getting from this program to be a better consultant to those who practice open science and not accidentally or unintentionally lead people down a road of proprietary solutions. So I've gained quite a bit of exposure in this program in terms of understanding what the key signs are of maybe accidental closed science as opposed to intentional open science. And I've got some examples of both my favorite takeaways from the course, as well as how I'm going to use it to become a better consultant and be prepared to support a citizen of the open science community who's engaging in scientific research. To give you a bit of background of the kind of works that I have done in the past, whether it's assisting open research or just commercial solutions, usually I'm consulted in to create a kind of test bench for types of things that are being tested. My main engineering background is in semiconductor devices and how they're being tested. And here's an example of using electronics and photonics in the same device, which is quite a new field that's growing even more, and of course getting more government interest from the UK. And so where I would probably get involved is sitting down with the researcher and understanding what types of signals they believe they're going to be running through their research material. And I would create a test bench around that, along with the correct signaling, synchronization, and timing that would actually prove that the results are valid for whatever it is that they're testing. And so I just put this up as a graphic to sort of give you an idea of what I've worked on. And then, of course, once the data is collected, often I might be a little hands off from that point, and that's where the research takes over. Although I have an understanding of research data and how it can be modeled and collected, usually it's the individual I'm working with who will then take that further and make sure they have a known good platform for which to get data off of to then go ahead and produce reports and research papers and things like that. Where I want to use my knowledge that I've gained is I would like to be able to, at the early stages of the conversation, of the consultation, be alert to the comments they're making about open science, and also for myself to put it as an option on the table so that if, for example, maybe some research must remain proprietary, perhaps the results or something similar could be marked, could be licensed in a way that it is open for that data to be reviewed in the future. Where I have to admit that often my understanding of deep research topic, like here's an example of a neuroscience-based paper that it's definitely not in the field I understand at all, often gets converted. So the bottom end is sort of how someone might present their symbolic math of what they're trying to achieve. And then I would tend to use software on the top to create a graphical representation of that code. And as you can see, there are some, for those recognize what this is, it's LabVIEW code, which is often considered a closed type of paid for software environment, as opposed to sort of free software like Python. But it just goes to show that that's where the industry was. And of course, I'm noticing that things are changing to be more and more open. So the 3 points that I have learned and wish to take away fall into the category of open science is only possible through intentional actions. You don't accidentally have open science. And so I now have an awareness of Zenodo and ORCID. Again, not being a researcher, these have been not on my radar. And then open is defined as sort of transparency, collaboration, accessibility, and that there should be data management plans alongside the typical type of plans I make that are things like software requirements gathering and software delivery. So having had a quick look through Zenodo, the kind of information that I found there that is useful to me is the data sets. And initially, I was concerned about the fact that Zenodo is sort of a pre-publishing application, pre-published data platform. But actually, I've realized that often when I make a test bed, having realistic data that I can run through it to see if I get similar results is a good way to test it to make sure that it's a usable foundation for the researcher I'm consulting. In terms of one of the sessions, session number 3 is the one that I took quite a lot away. And I do thank that presenter as well as all the presenters that actually just because something is online doesn't mean that it's open, even if that's what the researcher intended. So therefore, applying open licenses to the data actually enables the legality for someone to reuse that those data sets. I was quite familiar with open source as software and licenses for that, but never for the data sets. And then finally, in one of the last sessions, if I had to highlight a point here, sort of in the bottom left in the early stages of consulting, that's where I would come in with things like the data management plans. And I have to agree, a lot of what's on this slide is exactly the way that research goes, the one that I'm consulting on. And so my conclusion is have intentional behavior, be open to the idea that open science is an option. Otherwise, proprietary is the only way it's going to go because it's not licensed the right way. And finally, listen out for the keywords that a researcher might be saying that implies they want to retain the openness in one direction whilst having to maintain some level of proprietary development on the other side. So I want to thank everyone who was involved, the organizers, and actually all the chances that I've had to talk with other individuals on all the breakout sessions. It's really nice to talk with individuals who are polite, experienced, and scientifically astute to make sure that we can all really share our what we do in our daily lives with each other. So thanks again. If you'd like to connect, you can find me on LinkedIn or on the Slack.
Thank you, Georgios. It's super nice to have you actually, because most of us from a research environment somewhat way, even we don't want ourselves, we feel like towards the academia goes that we find ourselves involved with open science practices, but you come from a private consultancy expertise, and as you said, this involving with these practices and consulting your clients with open science tools and resources is intentional, and you have a very nice endeavor here that you wanted to take this step on this endeavor and guide them through how these tools can be applicable, especially in your domain. It's super easy to get through the private softwares and tools and choices. So, but instead you followed open science path is extremely inspiring. And thank you for sharing your experiences with us and your inspiration through this project.
Thank you, everyone.
Thank you. So if you have any questions for Georgios, so you can find his slides in the from a pad, and also you can share your feedbacks. So do we have recordings still?
Yes, we do have a
Okay.
few more recordings. I'm gonna play maybe 2 more, and then we can wrap up. I'm going to play Wen's presentation.
Hi everyone, my name is Wen and I'm the final year PhD candidate at the University of Essex in the UK. My research is in social epidemiology and life course research, and I study how the social and residential environments influence healthy aging. Today, I would like to briefly introduce my research, share the most valuable lesson I learned from the program, and discuss how I plan to incorporate open science into my future work. My research focuses on the understanding why some people age more healthily than others. Rather than viewing aging simply as the chronological age, I study aging as the multidimensional process, including biological aging, cognitive function, well-being, and physical functioning. I'm particularly interested in how neighborhood environments and social inequalities become biologically embedded across the life course. For example, I investigate whether living in disadvantaged neighborhoods accelerates biological aging or contributes to poorer cognitive health later in life. To answer these questions, I use large longitudinal cohort study with quantitative methods. Ultimately, I hope my research can help identify upstream factors that promote healthy aging and reduce health inequalities. Before joining the program, I mainly thought of open science as sharing publications or making data available after a project was completed. The biggest lesson for me was that open science starts much earlier.
It begins with planning transparent research, documenting analytical decisions, making workflows reproducible, and communicating findings in ways that are accessible to different audiences. This was particularly meaningful for me because I work with complex longitudinal datasets. Even when participant data can't be shared due to confidentiality, there are still many ways to make research more open. For example, sharing analysis code, documenting variable construction, publishing protocols, and clearly explaining methodological decisions all improved transparency and reproducibility. The program also reminded me that open science is not just about tools. It is about building a collaborative research culture where knowledge is shared and others can build on our work. Going forward, I plan to incorporate these principles throughout my research. First, I want to improve reproducibility by developing well-documented analysis pipelines and sharing code whenever data sharing agreements allow. Second, I want to make my research more accessible. Much of my work has implications for public health policy, so I would like to communicate findings not only through journal articles, but also through plain language summaries, visualizations, and policy briefs. Finally, I hope to contribute back to the research community. During my PhD, I have gained experience in longitudinal data analysis, multi-level modeling, and aging research. I would like to develop tutorials and practical resources that can help other researchers working with complex population datasets. I also believe open science is built through collaboration. I would be delighted to work with researchers interested in healthy aging, life course epidemiology, neighborhood environments, or reproducible research. I particularly welcome opportunities to exchange ideas, share methods, and develop collaborative projects across disciplines. The challenges surrounding population aging are complex, and answering them requires expertise from epidemiology, sociology, geography, biology, and data science. Open science provides an excellent foundation for these collaborations. Thank you, the organizers, mentors, coaches, and everyone in this community. The program has changed not only how I conduct research, but also how I think about research itself. Thank you.
Awesome. Congratulations. I'm gonna do one more. We're gonna see Claire's presentation now.
Hi, so I'm Claire MacDonald. I'm one of the participants in cohort 4 of the OLS Nebula Open Science course. And this is my course presentation on the 7th of July 2026 at the end of the course. I am the lead or head of the Clinical Data Science Unit at Manchester University NHS Foundation Trust. We are a small team, but we provide a very wide remit of a service supporting research, including open science research, providing infrastructure, data analysis, whatever is required for the project that we can facilitate. I'm registered with several professional bodies which promote open science and good practice as standard, and also I am a member of several groups that practice open science, such as the UK TRE community, SARTRA group, which is providing standards for TRE infrastructure and federation, and also the Besties group, which is a national group around research imaging best practices. We do publish some outputs on Zenodo already. The Besties Zenodo link is there. And aside from my professional day, my other jobs are I'm a full-time carer at home. I'm also a student still, and I am an emotional support animal to Teddy the dog. A bit of a role reversal for him and myself. So during this course, my key takeaway from this has been around the licensing, because we do apply licenses when we're publishing outputs, but we probably don't scrutinize them or give them the consideration that they deserve. We tend to apply a license because that's what everybody else does, and we maybe don't look at it in enough detail when we are applying the license. So usually we apply a Creative Commons 4 license, which allows basically sort of international reuse of the outputs. And like I say, we tend to do that because that's what everybody else in our sort of peer groups does. But I don't think we really think that hard about why we're doing that and what the future implications of it might be. A lot of things that we do and publish can't be published as an open license just because of the nature of the work in health data. But for some where it is, like the open science groups and things, the outputs are published in this way. And the outputs can be, quite often they are documents, but they can be software in GitHubs and things like that. They can be data, less often it's data, but there might be some data outputs in the future. Most often at the moment they are documents. And yeah, I don't think that we give enough consideration to maybe in 5 years, 10 years, whatever, what that license that we've published it under might actually mean and what its implications might be at that point down the line. And I found that session very helpful, actually. It made me focus a little bit more on the different types of license and why we might be applying them, and made me think about things we've already published and whether we need to review that or not. It did definitely give me a bit of headspace to think about that more. So I think the next steps, we are sort of in the middle of kind of open science processes, I would say. We are already publishing some things on Zenodo and GitHub. We do data sharing and some CC licensing. We are involved in open science communities, and we are leading on some of those communities and some policy building communities, but we're not necessarily applying everything from the build at the start. And I think for the next steps for us, we might need to plan a bit more with the outputs in mind from the beginning, what that licensing might look like, and lean more into that kind of leading practice pillar at the end of the presentation slide by Sean Olufemi on the 4th of June in that session, which was also very helpful. That kind of pushing ourselves more towards that final pillar and trying to increase engagement in our open science groups and encourage others to also think more from the beginning about embedding that in the design at the end. That's the end of my presentation. Thank you very much for the course. It's been very helpful and insightful.
Awesome. Congratulations. Yay. All right, so we are almost at the end. Sorry, Isil, for facilitating now. So I want to recognize that we have a time constraint here, but I will keep playing some recordings. We have 3 more. If you want to stick around and watch the recordings, you're totally welcome. But thank you all for coming. Congratulations for your graduation. You did all great jobs, and it's so inspiring to see all your presentations. Yeah, and there are instructions about the next steps to graduate in the Pharmapad. Basically, you need to have done what you did today, which is presenting and depositing your presentation on Zenodo. There's a post-cohort feedback form that you need to fill out so we can get the information that we need to send to NASA to get your badge. And that's pretty much it that you need to do. If you ask for microgrants, you should have heard from us before. So you need to fill out the form for requesting microgrants and reimbursements. And that's pretty much it. Yeah, Isil, do you want to say something?
I just wanted to congratulate everyone. It's been so inspiring for us to see like you benefit from the program, but also to see how it's actually there's always something for anyone with any intentions in any field to apply open science and benefit from it. It's nice to see this diversity and how it can find a body in your own research. And hopefully you also find it inspiring to hear those different stories and adaptations. And I guess we have 3 more, you said. Like I'm looking forward to like also to hear those.
Yeah.
And thank you for being here. So let's continue with them maybe.
Awesome. Okay, so I'm going to share the next presentation. Feel free to leave if you need to. Feel free to stay if you want to. The next one will be Silver.
Welcome to my presentation. My name is Silva Nwuguchiwenwa, and I'm a medical laboratory scientist based in Nigeria. And today I'm in
Did it stop?
Yeah, I'm gonna try to share again. Let me see. Stop share. Seems like my Zoom is crashing. Oh no! Am I moving? No? Okay.
No.
All right, let me... Yeah, I cannot do anything with Zoom now.
We can't hear you, Kristen.
Yeah, I was muted. I was saying I'm going to try to play another file because this one seems to be super, super heavy.
Okay.
And then I will share the screen after that.
Okay.
Let's
Mark
see
Joyce.
Adam's presentation.
Okay.
Okay, this is not working anymore.
Okay, I mean, if the link is shareable, maybe we can share it and or can we share it somewhere, like upload it to somewhere so we can put the link?
Yeah, we have the links on the Frama badge.
Okay,
Let me
then it
try
should be all right.
playing the recording and then sharing the screen.
Welcome to my presentation.
Can you hear
My
that?
name is Silva Nwuguchiwenwa, and I'm a medical laboratory scientist based in Nigeria. And today I'm incredibly proud to share my graduation project for the OLS NASA Nebula program cohort 4. The title of my project is Creating an Open and Reproducible Workflow for Analyzing Insulin Resistance Using Single-Cell RNA Sequence. This project marks a major milestone for me as a clinical scientist who has been in the wet lab space. This marks a transition into the dry lab and open science by giving me access to data sets and just a part of science that necessarily won't be accessible to me based on location and availability of resources. Okay, so to give you an overview of what my project, which I intend to start this July, to give you an overview of what it's about. This project is intended to build an open and reproducible single-cell RNA sequencing pipeline, right, accessible to the community of biological scientists. And I intend to leverage a public data set available on the Gene Expression Omnibus database. And the skill set I would be employing is computational bioinformatics and my basic laboratory scientist skill and molecular biology. It's important to point out this would not have been possible because it requires expensive local sequencing infrastructure. But due to open science, it is now accessible, and I intend on making my pipeline accessible to others as well. Why I chose this particular problem is because insulin resistance is a case that is often linked to obesity and subsequently, depending on the factors responsible, diabetes, which is something I see all the time. So the intention of this project is to study insulin resistance by accessing the cells responsible and trying to figure out what exactly is happening at the back end. Originally, traditional bulk RNA sequencing doesn't give insight to this data as much, and that was why I downloaded this data set, the 176171 from the GEO dataset database, and I would be working with that. Now, the open science framework I would be employing, first of all, the open data, which I obviously got online. And thanks to open science, I was able to access this. I didn't have to go to a physical location. It was online for me. And I was able to get the metadata and the matrix and everything I needed to work with. And also, I was able to access previous research in this direction that aided my understanding of the subject and the gap I'm trying to fill. Again, I would be documenting all my analysis on GitHub as a, a public space for other people who would want to work in a similar research to find data information and code blocks that would enable and help them. Another open science framework I'll be employing is the FAIR principles. So these data and the outputs that would be on GitHub are accessible and they are reusable. And my process of analysis would be openly documented with the steps being fully transparent, all to make sure that anyone who gets this particular data sets and gets my documentation will be able to understand and proceed from there. This is the pipeline I'll be working with. The downloading of the dataset, which I already have, the GEO dataset, the quality controlling, which I would be handling via the Python programming language framework, the normalization, the clustering, and ID, and I would be doing the interpretation publicly as well. So the aim of this entire project is to demonstrate that we can make science public using my GitHub and the documentation. I would create a detailed README document for it so that it's going to be clear. And the scripts I use would also be publicly accessible and enable reproducibility. So my project timeline is for this month of August to the month of July to August, sorry. I have currently downloaded the dataset and I would be starting work sometime next week, which is the second week of July. And by August, I expect that the work should be up there. And yeah, this project is going to give me a gateway into bioinformatics as a medical laboratory scientist wanting to do my my graduate program in computational biology and bioinformatics. Thank you, Nebula. Thank you for this program. Thank you, OLS, for this community. I learned a lot and I'm incredibly grateful to be part of this cohort.
Awesome. Congratulations. Let's see who's next. Adam and then Nazim. Let's see if I can share. I'll play the file. It's better.
Hi, I'm Adam. This is my OLS NASA Nebula program recap. So as a brief overview, I'm going to be giving an introduction and then talking about my learnings and then talking about the next steps. So for introduction, I'm the Research Culture and Quality Manager at Trinity College Dublin, which means I'm research support staff. I'm also the Director of Partnerships at FORT, which is the framework for open and reproducible research training. So I've got some previous experience with open research and also with open research training. I've seen the ecosystem evolve and kind of mature over the years. So a bit of an outlier probably for the cohort. My main aims at taking part were to gain awareness of any new open materials that were available, to pick up some new facilitation tools or techniques, to network and connect with the new generation, to support an organization that I value in OLS and a partner of FORT. And it was also a forcing function for me to actually complete OS 101. In terms of my learnings, with the content, the main learning was around the different types of metadata. With the facilitation techniques, I really liked the different options for written or spoken participation, how that enabled accessibility. Regarding networking, I think the OLS Slack is a really good addition to the course. And for myself, there's a bit of a missed opportunity. If I had more time, I'd have liked to have taken part in the coaching sessions as well. I really liked how the payment model enabled me to support the organization, but then also enable others to participate as well. And I liked how the commitment and the structure around the program really did serve as that forcing function, provided accountability for me to actually finally go through the materials and complete the course. In terms of next steps, I'm going to be looking to review the open research support and capacity at Trinity and think about questions like where is open research capacity needed, so which disciplines, and within the research support team as well. I'm going to consider how that capacity could be increased, so either internally through direct support from research support staff, through creating resources or community building, but then also utilizing external resources, materials, or training as well, as these are often openly licensed. Also thinking about what strategic projects could address this capacity. So is there a need for more signposting materials? So for example, slides or web pages. So when we go out to talk to researchers, we can point them to more help. Also thinking about creating communities of practice, or is there a need for a champions network to really embed these ideas and provide a bit more of that peer-to-peer support? And finally, is there an opening for perhaps train the trainer support as well? So to get more upskilled researchers within those disciplines to provide the training themselves, or the research support staff can take part in that as well. That's the end of my recap for the OLS NASA Nebula program. Thank you.
Team Bioinformatics. Yay. All
And the
right,
Ford
congratulations.
community is one of the, I guess, the broader community. So it's nice to know that they are also the part of the program and benefit from the reciprocally. We benefit from their amazing tools and documentation. So it's so nice to see them here.
Yeah, really.
Perfect.
Yeah, we have one last recording. Let's try that.
Hi, my name is Nassim, and I'm a PhD student in physics at SFU Simon Fraser University. And for the Nebula, I work on the bridging of physics and neuroscience, explaining theory of the decision making. So, and what was our main idea and main question for our research? We try to understand how we make decisions for animals, especially when balancing immediate rewards with the promise of something better. And our approach was using physics-based model to understand the brain's decision-making process. We used the data which collected at the Labbage lab at the Indiana University. It comes from 56 experiments. In each experiment, a rat put in the box with two lever presses, left and right, and they should choose between these two lever presses. So we have two kind of lever presses: immediate lever press, which deliver running reward, and it starts from 3 pellets wood, and it decreases by and the immediate reward decreases by choosing the immediate reward or the next choice. And also we have the other lever presses, delay lever presses, which deliver maximum as 6 pellets wood, but after a delay time, 1 second or 8 seconds. So the challenge that I run into was that this process is complex and stochastic, and it is hard to see the simple rules that govern how an animal or rat adopts its behavior. So So we try to understand how happen in decision making for the rats. We use computational modeling, which called a reinforcement learning model, in order to simulate learning and find out these simple patterns. And in other words, we try to analyze population level behavior. So we derived deterministic or the differential equation from the stochastic simulation reinforcement learning model. So in the simple word, we use the reinforcement learning model or computational model and find the equation for the estimation of the delay and immediate reward for the rats, and also find how immediate reward change during the time. And by solving this equation, we understand that their decision works like a spring system or a damp harmonic oscillator in physics. And in this system, the inverse of the learning rate or the speed of the learning acts like the mass in the physics, and the reverse sensitivity acts like a spring strength in physics actually. So we use this model, and we understand that solution for understanding the decision making is using the spring theory. So the challenges that I faced during my research was that my work is interdisciplinary and making it hard to explain and to find collaborators, especially when I participated in different conferences. It is hard to explain my work for the other person, for example, neuroscience people or psychologist person, and so on. So by participating coaching session, they suggested me to translate my research for different audiences, and for physicists and for neurosciences people or psychologists. And also, I wonder if it is possible to test my model in different data, and they actually suggest me to create a public GitHub repository for this research to share my code and methods in order to find the people that they have a common interest with me, and build a community as well as an online platform to connect with the both physicists and neurosciences people. So thank you for listening, and if you have any question, please contact me.
All right. That was it. We did it. It was a bit longer than expected. I totally miscalculated how much time it
No,
will
no,
take.
it was nice to like take our time and listen to all this amazing work and achieved by everyone. So I really enjoyed. Thank you so much. There was a lot of learning for myself too. Thank you.
Amazing. All right. Thank you all for staying a little longer to see all the recordings, and you're free to go now.
Okay.
Thank you.
Thank
Thank you for
you.
coming.
Bye,
Bye.
everyone. Congratulations again. Bye.